The nature of the tail end of the term here. We've done some of those basic series questions. I just want to show you through example 3 here. It is not much of an extension on what we've been doing. It follows the same process, and if you've understood the process previously, you should follow along what we're doing here pretty well. So this is our proposition. Our proposition is, so this is my statement. Remember, state. Here's my statement. 1, prove that for n is greater than 0, 1 plus 9 plus 9 squared plus 9 to the 3. Okay, so we need to rewrite the statement. That's the very first line there. We need to make the statement. Okay, this is what we're testing. Testing improvement. Okay, then we need to test it. And it says test for n is 0 because we're always testing the first case. Alright? Because the first case has to fall over, the first domino has to fall in order for us to have a successful series of dominoes falling over. So in this circumstance, we're saying when n is greater than 0, so that means we're greater than or equal to 0, so that means our lowest value of n is 0. Okay, so 9 to the power of 0, let's do that. The left-hand side is going to be 9 to the power of 0, which is 1. All right. The right-hand side is going to be 9 to the power of 0 plus 1, take 1 on 8, which is 9 to the 1, take 1 on 8, which is 9 take 1, which is 8 on 8, which is 1. We have the left-hand side equals the right-hand side. Therefore, P of 0 is true. Okay, so following our same procedure, we've stated, we're testing, now we're going to make the assumption. We're going to assume P of K is true. If it's true for P of K, so if P of K is true, then 1 plus 9 plus 9 squared plus 9 to the 3 plus all the way up to P of K equals 9 to the K plus 1, take 1 on 9. That's our assumption. Isn't it on 8? 8, thank you. Let's do the proof. Test, state, test, assume, prove. So now we're going to prove P of K plus 1. Okay? And P of K plus 1 is going to be 1 plus 9 squared plus 9 to the 3 plus 9 to the K plus 9 to the K plus 1. Okay? And then we expect it to be 9 to the K plus 2, take 1 on 8. Okay, so we've got a direction for which we're aiming. Alright, we're aiming for what is on the right hand side there. Yep, K plus 1 plus 1, K plus 2, yep. So we'll start to do those little shortcuts now that we're getting a bit of the hang of it. I'll do my rolls. I'll stop now, guys. I'll finish this and then I'll do the roll. What a naughty boy.
It's in the video now.
Okay, so we're up to proving it. This is what we've got and this is where we're aiming, and we always do the substitution, don't we? Remember, this is P of K and we're assuming that P of K is true. So let's perform our substitution for P of K. That's this part, okay? That substitutes to 9 to the K plus 1, take 1, on 8, plus 9 to the K plus 1. That's it. Okay. For us to smash them together, we need them to have the same denominator. So we can make this 8 times 9 to the K plus 1 on top of 8. Alright, that's a legitimate operation. Times by 8, divide by 8. Now they have the same denominator, which means I'm going to collect them. Okay, so I should, make the statement left-hand side equals. Okay, so we're manipulating the left-hand side. We've got the same denominator, so we've got 9 to the K plus 1. Plus 8 lots of 9 to the K plus 1. Take 1 on top of 8. maybe you can see the solution. If we have, here we've got one lot of 9 to the k plus 1, and then we're adding 8 lots of 9 to the k plus 1. Do you see how they're like terms? They have the same base and the same variable. Okay, so here's one lot of 8 to the 9 to the k plus 1, and here's 8 lots of it. And so we can add them together. You can think about it, again, like if we go let A equal 9 to the k plus 1, we've got A plus 8A. It simplifies to 9A. So this, we've got one lot of 9 to the k plus 1, plus 8 lots of 9 to the k plus 1. That is 9 lots of 9 to the k plus 1. Okay. These have the same base, which means we can add the powers together. Alright, so we're going to have 9 to the k plus 2. Take 1 on 8, which is the right hand side. Explain. Okay? Because P0 is true, and P of k plus 1 is true, if P of k is true, then Pn is true. Or n is n greater than or equal to 0, and n is an integer. Okay, I needed to make both statements because we can't just say it has to be a positive integer. It's positive because 0 is not an integer. Okay, so we're saying it can be 0 and larger than 0, but it has to be a whole number. Nice one. Okay, so you guys can have a go at example 4 there if you like. It very, very similar to the one we just did, and then that will lead into series of sums and products there. Okay?